Hi, good morning. It's Gene from maverickstar Observatory. A couple of things I wanted to discuss in this video, and I've set up a couple of experiments, so if you're interested in those practicals that we do sometimes to explain some of the anomalies that take place in our world and almost certainly in our solar system, then hang on to that. But before we do, big thanks to a few people that have been chipping in a bit of support for the observatory. In particular, John this morning made a very nice donation to the channel, as do some of you already, but I think it's worth a shout out when someone throws in $100 to keep the observatory running. So amazing. If I can encourage just a few more people to see the worth in what we do here, then that'd be great. So the links are down there. Anyhow, let's get on. As you can see, Pluto's strange atmosphere just collapsed. I've set up a couple of experiments. First of all, the one explaining why Pluto's atmosphere may have collapsed, and that could be due to the fact that the heliosphere has shrunk and it has left Pluto out of the heliosphere, and therefore its atmosphere collapsed as a result of no longer benefiting from those solar radiation heating that it usually does. The other reason could be simply that the magnetosphere collapsed, as we saw as happened to another planet in our solar system, Mars. So if you read down further on in this description of why these astronomers believe this may have happened, you'll see there is a problem. However, the model suggests that Pluto's atmosphere ought to have shrunk by 1% since 2016, not the 20% observed by the Japanese team. So there may be some other factor at work that is not accelerating Pluto's atmospheric collapse. So they're not sure. So it could be the fact that we've been experiencing a low solar output for the last 33 years and it's been declining, and therefore the heliosphere would have shrunk. And the experiment I'm going to show you is a good analogy of how a heliosphere works. And there's a couple of dots on the experiment that as the heliosphere expands, it covers Pluto, and as it shrinks, Pluto, you will see, falls out of the heliosphere. So well worth watching. So they're not quite sure why Pluto has lost its jade green beautiful atmosphere that it used to have. And I've got to say this, it was visible thousands of years ago by the Mayans, and the only reason why we discovered it had a blue jade green atmosphere was because of the space telescope Hubble, enabling us to do that in the last 30 years. So it has had an atmosphere for as far as we can work out, at least going back a few thousand years, maybe 2 to 5,000, maybe 6,000 years ago. Why it's lost its atmosphere now could be due to the fact that we are living in a time where the heliosphere is shrinking due to the low solar output. That's why we've got low sunspot numbers, and that, as you know, is because the heating in the umbra where the sunspot forms is making it too hot for the umbra to form in the first place. Therefore we don't get a sunspot, and therefore with low solar output our heliosphere shrinks, and that could have left Pluto out in the cold, and that could have caused the atmosphere to condense and freeze and fall back down on the surface of the planet. We just don't know. Or the other thing could have been as what happened to Mars. It has now lost its interior mechanism which creates the dynamo, and therefore creates the poles and the magnetosphere which protects the planet, and therefore it has lost it. Time will tell whether it comes back. I believe, according to this article, they believe that it's just the distance sometimes that Pluto goes out into the outer epigees of our solar system, and therefore it cools the planet down, puts it further away from the sun, and therefore the atmosphere collapses. So this might be something that these astronomers believe happens regularly. We'll just have to wait and see in time. But I will say this, Mars lost its volcanic activity and then I believe the core solidified, which meant that the molten lava and heated metal in the core was no longer able to swirl round and generate the magnetosphere. If we use the standard model of how they believe Earth's magnetosphere is created, then that could have been the reason why Mars lost its atmosphere and looks like it does today. But you know, both these planets acting in the way they have in our lifetime shows us something, that you know, it is not uncommon for great changes to take place. And you know, who knows, you know, great changes could have took place in the Jurassic periods of our Earth, and that could have been what caused all the dinosaurs to apparently have died at the same time. That means that, you know, we live in a very hostile environment, even though we are currently protected by a weakening magnetosphere. And it just goes to show, you know, that we shouldn't take these things for granted, because it's not to say that they're going to last forever. There is nothing really that lasts forever in the universe, if you think about it. Our sun will eventually lose its power and fade out. It may even supernova at some point. We just don't know when that will be or why that will be, because we're very primitive in our understanding even today of how these things really work. So, you know, it is only by modelling, studying, using the scientific method that we are able to slowly piece together the little bits of the puzzle and get an image of the picture that starts to emerge, and get a better understanding of our world in which we live in and its current position in this solar system. And then if we push out a little bit further, where we are in our galaxy and how things interact with us here. So again, we shouldn't take it for granted. So I'll show you the analogy of the heliosphere now, the little experiment I've done for you guys, and you'll get an idea of what I'm talking about. Will give a better analogy so that you understand what could possibly be going on with Pluto's atmosphere. That is, if we eliminate the fact that it could have just lost its atmosphere due to a collapsing of its magnetosphere. We have seen this happen in our solar system before with Mars. But just to give you an analogy of how our heliosphere works, if you imagine the blue dot in the middle to be our sun, and a little bit later on I'm going to switch on the water, and you're going to see it form a ring of pressure as the water hits the plate. It's a good analogy for the way our heliosphere works. But if we imagine this little dot here to be Pluto, when I increase the flow, Pluto, you'll see the ring of pressure of water you know, covers Pluto and therefore protects it with the heliosphere. But as I decrease the pressure of the water, the ring will move outside, move closer towards the dot in the centre, which represents our sun, and Pluto will be outside that ring. Very similar to what is taking place with our heliosphere right now, and I'll show you how that works. So you can see a little pressure ring around the dot in the middle. Now that's our heliosphere as it probably is working right now. Very low pressure due to low solar activity. But if I increase the pressure of water, you'll see that that ring expands to cover the second blue dot, as you can see now. And that would be, you know, if our sun was emitting regular sunspots, and you know, the heliosphere would be inflated to cover our outermost planet, Pluto. It's just a good way of trying to understand how our heliosphere works, and I think it's a good analogy of showing you that. So if I decrease the pressure, which would represent the sun in a grand solar minimum now, you'll see that the secondary dot starts to lose the protection of the heliosphere. And then if I increase it again, which would represent normal solar activity, the blue dot is protected by the heliosphere. And just to decrease the pressure of the water, which represents a decrease in solar activity, you can see how the heliosphere collapses in on our solar system and leaves Pluto out of that protected heliosphere bubble. Just once again I'll increase it. There you go, once again, the heliosphere, because of the pressure of the water has expanded, it represents more solar activity and therefore Pluto is protected once again. So hopefully you get a good analogy of how our heliosphere works after that little demonstration. Now I've got another demonstration for you regarding something else that is commonly asked in the comments section, and that is, can planetary alignments and their magnetic fields affect our magnetic field? Or could a planet X or planet 10 or Nibiru or blue star Katrina or any of these that are entering our solar system affect our magnetic field on our Earth? And is that what's causing the magnetic pole reversal? And the simple answer is no, they do not affect our planet's magnetism. It is not what's causing the magnetic reversal on our planet right now, and hopefully this next experiment or practical will show you guys why that is. So I'll run that for you now. It would be a good analogy to give you guys with regards to some of what's being said at the moment with regards to interference of magnetic fields of planets aligning. What we've got here is obviously a little globe with a compass on the top, and if we set it up with another magnet to represent just something just to keep the needle pointing towards the magnet, as we switch it on, you'll see that the red pointer on the compass always tracks the magnet that it's in its vicinity with. So what would happen if another planet or a series of planets aligned with ours? How would that affect our magnetic field? And I've got another magnet which I'm going to put in the vicinity, and there you'll see that it disturbs the track of the magnet as it was. This would create, as our Earth rotated, a massive wobble where the needle, as you can see, flicks from one magnet back to the other. So this demonstrates that even though we've got some planetary alignments, they're not interfering with our magnetic field, and therefore that outrules some of the other theories that people have suggested might be the case of why our poles are migrating. One of those being Nibiru, a planet entering our solar system with a strong magnetic field might be the cause of the magnetic poles reversing, and that's not the case, and I think this experiment proves that. I'll just remove the interference magnet now, so you'll see that once the interference magnet's out the way, it no longer affects the position of the magnetic compass. As you can see now, when it settles down, it just constantly tracks the magnet. It never leaves the course of what it's on. So again, if another magnet was to be introduced to this, which would represent a planet coming into our solar system, you'd see how it would affect our magnetic pole. So I'll just bring the interference magnet in again. You can see that the compass needle diverts towards the interference magnet as it rotates, and this is exactly what we would see, and this isn't happening. So there can be planetary alignments, and these planets can have magnetic poles, but they certainly aren't affecting our magnetic field, or even our dipoles over the northern hemisphere in this manner. We would pick this up every day as the Earth rotated, and as we got closer on our orbit around our Sun to the interference planet or the interference magnet, it would certainly divert towards that planet. Again, this is something that we're not seeing, so because of this we can outrule any alignments within our solar system affecting the magnetic North Pole at the moment. We can also outrule any planets that may be entering our solar system, such as blue star Katrina or Nibiru or any other planet that we've heard about like Planet X or the 10th planet. It's not the case, and this proves it. So once more, I'll remove the interference magnet, and you'll see that when it settles down, it is only attracted to the one magnet, and that red needle never diverts. It's a very sensitive compass that I've got on there, and the reason for that is because I drained the fluid out of it, because I wanted a very sensitive compass needle that would show any discrepancies, you know, in experiments like this. But you can see when it settles down, it really doesn't leave the polarity of the magnet that it's attracted to. But when we bring in once more the interference magnet, you can see it's diverted as it passes by it. So there's no other planets, either by you know, alignment, or planets that are coming into our solar system at the moment that is interfering with our magnetic north pole. It is a process that our Earth is going through. So hopefully guys, you'll understand now why a planet entering our solar system couldn't affect our Earth's magnetic field, and therefore could not be the cause of it going through its magnetic reversal, and likewise why any alignment of any configuration of the planets within our solar system, whether they align or not, would again not be responsible for causing the Earth's magnetic field to change, as you just saw in that little analogy that we did with the experiment of adding an interference magnet to the vicinity of the compass as it was rotating round. You could see that before the interference magnet was introduced, it was locked on to that other magnet. It was only when we brought the interference magnet in, as we would expect, you know, if a planet was to align or a planet was to come into our solar system there and it had the ability to affect our magnetic field, we would see the changes immediately, and we would see them within a 24-hour period because of the way our Earth rotates once every 24 hours. So hopefully we've cleared up two things. The analogy, first of all, of Pluto. As the heliosphere collapses, it might not bathe Pluto in the radiation that it's accustomed to, therefore the atmosphere of Pluto maintains its beautiful jade green colour as it has done for thousands and thousands of years. There could be also another reason why that is happening, and you know, the astronomers you know, that have brought it to our attention about the planet's atmosphere collapsing right now also agree that there could be other reasons. Now, it could be that the core on Pluto has stalled. Whether that being temporary or permanently is just a matter of time will tell. But it's not uncommon for this to happen. It happened with Mars, our neighbouring planet. What caused that to solidify in the first place, therefore, you know, breaking the regular magnetosphere anomaly that protected the planet and its atmosphere and the water on its surface, which we know through studying the terraform, is still for debate. But we know it has happened to now not just one planet in our solar system, but now two, our neighbouring one, Mars, and now Pluto. So time will tell. The thing is here to remember, guys, is that we shouldn't take anything for granted. You know, there are other anomalies taking place with some of the planets in our solar system, and have done before. If we look at Jupiter, the two rings that run around Jupiter, not Saturn like Saturn's rings, I'm on about the jet streams on Jupiter. They disappeared for a period of time and then came back. You know, it just shows you that, you know, climate on other planets also has dramatic effects, and that we live in a very fluid environment in our solar system. But you know, it is of concern when we see solar activity over the last 33 years declining to where it has done now, you know, giving us this grand solar minimum period. But it's not the first time this has happened, and again, that is not the cause of our magnetic poles reversing on the planet. Our magnetic poles are reversing on the planet is because something is taking place within the core, where the magnetosphere sets up the conditions to produce dipoles, magnetic poles, and also a protective magnetosphere. And I say this, you know, we couldn't have a worse time. We live in a time over the last 100 years where we are now witnessing for the first time, possibly in 780,000 years, the real effects of a magnetic pole reversal on our planet, and we are very close to that really taking effect. Could possibly be within 2.6 years. That's really alarming in itself. You know, our magnetosphere will severely be affected and deplete at that point in time, leaving us exposed to more cosmic rays and therefore more dramatic climate changes on our planet. On top of this, we have a low solar output due to the grand solar minimum. Low sunspot numbers have been recorded to deplete exponentially over the last 33 years, and we still haven't reached equilibrium. So our primary defence and our secondary defence are weakening as we speak right now, and this in turn allows more cosmic radiation to enter our solar system and then into our atmosphere as a result of the depleting magnetosphere. Real shocking times we're living, guys, and these things are noticeable, how they are changing the climate. Again, over the last 33 years we've seen more movement of the magnetic North Pole in shortest period of time. Just to put it into perspective, from the 1900s to 1990 we saw the magnetic pole migrate 500 miles. From 1990 to the current date we've seen it migrate over 1,000 miles. Doubled its speed in not even half the time. So we are rapidly approaching a point in time where we will be seeing some dramatic effects take place on our planet, and as you know, we are poorly prepared for this. Also, you will know that even these big organisations aren't joining the dots as what we are here. Now, we cannot be the only experts in the field of geomagnetics and how geomagnetics plays out on the climate of the Earth, but you know, if you watch the video yesterday that we put up and the one day before, it is without a doubt showing clear signs that magnetics are, you know, having a role in playing out on our climate as it's changing. And for the last 33 years we have seen two things. We've seen a deplete in the sunspot activity or the solar activity. We've also seen a rapid movement of the magnetic North Pole. And both of these in turn allow more cosmic rays, allow cloud seeding, changing the jet stream behaviour, and therefore delivering, you know, unusual climates and seasons, and that's what's catching out our farmers right now. Not only that, it is knocking out good arable agricultural land that we are reliable on to supply the world and its 7 billion inhabitants of their food. You know, I showed you yesterday in the charts of Canada and Russia increasing in magnetic intensity and Canada at the same time decreasing. I said what we should see is a decline. As we see the decline in the intensity over Canada, we should see it get warmer. Now, I believe it's sensitive to probably 5 to 10 degrees Celsius in change. Now, with the jet streams being out of control, that means that there's still leeway to recover, you know, that warmer period. What I'm saying here is you might not dramatically notice it, that 5 or 10 degree increase or decrease in the temperature, because the jet streams are not behaving as they should do, and therefore we're going to get, you know, on cold days in Canada, you know, a lot of moisture, humidity, which is going to turn into snow as it precipitates, and you're probably going to get more snowfall. You might experience a colder winter in Canada, and you might say, Gene, it doesn't fit the bill, what you're saying. Well, you know, the reason is because not only will Canada, as we can see clearly if we look at the two charts yesterday I showed you, Russia is a lot colder than what Canada is. A lot colder. Clearly you can see more purple over Russia than you can over Canada, but we have to incorporate the jet streams as well, delivering more snow at that point in time, and the winds also that go along with the jet streams. And this is why it becomes really hard to not only visually see the changes, but to predict the changes. This is something we're trying to effort here at the observatory, so we can give a clear picture of what we can expect as these things deteriorate. And the only way we can do that is by using scientific methods of observation, recording information. And if you follow this channel, you know we have now one of our magnetometers in Canada, we have one in Arizona, we have one in Hong Kong, Perth, and on the Gold Coast of Australia. And we also have equipment here monitoring the magnetic North Pole migrating every 3 seconds, so we record on a real high resolution. And we seem to be the only ones informing the public up to date of current changes, which is pretty shocking when you consider the amount of money that these larger organisations that we would expect to reveal this information failing to do so. So, you know, it is only because we've had a few people donate that has enabled us to get where we are. And we're approaching the beginning of a new year, 2021, and we've got some you know, things that we want to achieve early in 2021 by getting more equipment out to different locations. The only way we can do that and build the equipment is by funding, and unfortunately it comes down to you guys that are listening to this right now. And I know it's difficult sometimes, it's a bit of a ball ache for you to get your credit card out and fill it out and donate to that link that is massively overlooked. As you can see, over 7,000 people visit our website to get a grip on what's going on. Like tomorrow we'll be doing the Earth Alpha at Glance. Requires, you know, various equipment to give that information to you guys. But yeah, the only way we can continue doing it is by being publicly funded. You know, to date we've had, you know, some massive milestones and achievements, and that is only because we've been funded. And you know, it needs to be continuously funded if we are going to keep informing the public. This website might not come across as professional as what some of the other professional websites and editors do, and that's because we're not filmmakers here. You know, we're scientists, or I'm a scientist, and I try and put just the facts in a video for you. You know, I haven't got hours to spend editing and setting up green screens. I wish I did. We do have the facility to do it now, but it's very difficult to do it. And, you know, also at the same time run the observatory and collect all the data and process it for you guys. So you just have to put up with that at the moment. I would love nothing more to raise enough money to be able to afford to pay a couple of other people here at the observatory to alleviate some of the workload. But unfortunately we barely cover a single person's salary, you know, despite having 30,000 people subscribe to YouTube. And the only thing I can say is, you know, there isn't another YouTube channel out there that does what we do, and there certainly isn't another website like what we've got that covers all the anomalies as well as collects and processes the data like we do. So, you know, we deserve a little bit of funding, and you know, I'm really grateful for the funding that we've had to date, but it needs to continue, guys, more so now than ever. Look, can you believe one of our planets in our solar system's atmosphere has just collapsed? That puts it, I hope, in perspective for you guys. So, you know, the links are down there if you want to help support us. I will not take up any more of your time. Hopefully you've got something out of today's video, and I'll say what I usually do. Take care, look after your loved ones. We'll be back tomorrow with Earth Alpha at Glance, and as always, bye for now.